Welcome, everyone, to tonight's journey into the fascinating world of quantum optics and photonics. Tonight, we'll be exploring the seemingly magical realm where light particles, or photons, are harnessed for ultra-secure communication. Prepare to be amazed as we unravel the mysteries of how these tiny packets of energy can revolutionize the way we protect our information, offering a level of security that was once thought impossible. So, settle in, relax, and let's delve into the quantum realm together. Imagine a world where your most sensitive data is impervious to eavesdropping, where your private conversations remain truly private, and where the risk of cyber attacks is drastically minimized. This is the promise of quantum communication, a field that leverages the bizarre and counterintuitive principles of quantum mechanics to achieve unparalleled security. At the heart of this revolution are single photons, individual particles of light that can be manipulated and controlled with incredible precision. These photons, behaving according to the laws of quantum physics, offer a unique way to encrypt and transmit information, making it virtually unhackable. The fundamental principle behind quantum communication is quantum key distribution, or QKD. This technique uses the properties of quantum mechanics to generate and distribute encryption keys between two parties, typically referred to as Alice and Bob. These keys are then used to encrypt and decrypt messages using classical encryption algorithms, such as ES. What makes QKD so special is its ability to detect any attempt to intercept or eavesdrop on the communication channel. This is achieved through the principles of quantum superposition and quantum entanglement, which we'll explore in more detail later. If an eavesdropper, often called Eve, tries to measure or intercept the photons carrying the key, she inevitably disturbs their quantum state, leaving a detectable trace that alerts Alice and Bob to her presence. But before we dive deeper into the intricacies of QKD, let's take a moment to understand what photons are and how they behave. Photons are the fundamental particles of light, the smallest units of electromagnetic radiation. They have no mass and travel at the speed of light, approximately 299,792,458 meters per second. Unlike classical particles, photons exhibit wave-particle duality, meaning they can behave as both waves and particles. This duality is a cornerstone of quantum mechanics and plays a crucial role in quantum communication. When we talk about single photons, we're referring to individual, isolated photons that are emitted and detected one at a time. Generating and controlling single photons is a technological feat in itself, requiring sophisticated lasers and detectors. These single photons are the building blocks of quantum communication, carrying information in their quantum states. Now, let's delve into the concept of quantum superposition. In the quantum world, particles can exist in multiple states simultaneously until measured. This is known as superposition. For example, a photon can have both vertical and horizontal polarization at the same time. Only when we measure its polarization does it collapse into one specific state. This property is used in QKD to encode information in the quantum state of photons. Alice can prepare photons in various superposition states, representing different bits of information. Bob, on the other hand, measures the photons to decode the information. The act of measurement, however, inevitably disturbs the superposition state, which is key to detecting eavesdropping attempts. Another crucial concept in quantum communication is quantum entanglement. This is a phenomenon where two or more particles become linked together in such a way that they share the same fate, no matter how far apart they are. If you measure the state of one entangled particle, you instantly know the state of the other, even if they are separated by vast distances. Einstein famously called this spooky action at a distance. In QKD, entangled photons can be used to establish a secure communication channel. Alice and Bob can share entangled photons and measure their properties. The correlations between their measurements can be used to generate a secret key. If Eve tries to intercept the entangled photons, she will disrupt the entanglement, alerting Alice and Bob to her presence. One of the most well-known QKD protocols is BB-84, named after its inventors Charles Bennett and Gilles Broussard. In this protocol, Alice sends photons to Bob, encoding each bit of the key using one of four possible polarization states: vertical, horizontal, plus 45 degrees, or minus 45 degrees. Alice randomly chooses one of these four states for each bit she sends. Bob, on the other hand, randomly chooses to measure each photon in either the rectilinear basis, vertical or horizontal, or the diagonal basis, plus 45 degrees or minus 45 degrees. After Bob has measured all the photons, he and Alice publicly compare which basis they used for each photon. They keep only the bits where they use the same basis. These bits are then used to generate the secret key. If Eve tries to intercept the photons, she will have to guess the correct basis to measure them, which introduces errors that Alice and Bob can detect. This is how BB-84 ensures the security of the key distribution process. Several other QKD protocols exist, each with its own advantages and disadvantages. Some protocols, like E91, rely on entangled photons, while others, like SAR-04, use decoy states to further enhance security. Decoy states are photons with different intensities that are randomly sent along with the signal photons. These decoy states help to detect eavesdropping attacks that exploit imperfections in the single photon sources and detectors. By analyzing the error rates of the decoy states, Alice and Bob can estimate the amount of information that Eve might have gained and adjust their key generation process accordingly. The choice of which QKD protocol to use depends on the specific application and the available technology. Now, let's consider a real-world example of quantum communication. In 2016, China launched the world's first quantum communication satellite, Mischius. This satellite was designed to test the feasibility of long-distance quantum communication. Mischius has successfully demonstrated quantum key distribution between China and Europe, paving the way for a global quantum communication network. The satellite uses entangled photons to establish secure communication links between ground stations. The results of these experiments have been remarkable, demonstrating the potential of quantum communication to revolutionize data security. MISHIAS has also been used to conduct quantum teleportation experiments, where the quantum state of one particle is transferred to another particle over a long distance. The applications of quantum communication are vast and far-reaching. One of the most promising applications is in the financial sector. Banks and other financial institutions need to protect sensitive data from cyber attacks. Quantum communication can provide a secure way to transmit financial transactions and protect customer data. Another important application is in government and military communications. Governments and militaries need to protect classified information from espionage. Quantum communication can provide a secure way to transmit secret messages and protect national security. Quantum communication is also being explored for use in healthcare, where it can protect patient data and ensure the privacy of medical records. As quantum technology continues to advance, we can expect to see even more innovative applications of quantum communication in the future. However, quantum communication is not without its challenges. One of the biggest challenges is the distance limitation. Photons can be absorbed or scattered as they travel through optical fibers or the atmosphere. This limits the distance over which quantum communication can be achieved. To overcome this limitation, researchers are developing quantum repeaters. Quantum repeaters are devices that can extend the range of quantum communication by using quantum entanglement to transfer the quantum state of a photon over long distances. Another challenge is the cost of quantum communication systems. Quantum communication systems are currently very expensive, which limits their widespread adoption. As the technology matures and becomes more widely available, the cost is expected to decrease. Despite these challenges, the future of quantum communication looks bright. Researchers are making significant progress in developing more efficient and cost-effective quantum communication systems. Quantum communication is poised to revolutionize the way we protect our information, offering a level of security that is simply not possible with classical methods. As quantum computers become more powerful, the threat to classical encryption algorithms will increase. Quantum communication will be essential to protect our data from these future threats. The development of quantum communication is a race against time, as we strive to stay ahead of potential quantum attacks. The potential benefits of quantum communication are enormous, and the race to develop this technology is well worth the effort. Now, let's explore some of the key components of a quantum communication system. The first component is the single photon source. This is a device that emits individual photons, one at a time. Single photon sources are typically based on quantum dots or spontaneous parametric downconversion. Quantum dots are tiny semiconductor nanocrystals that can emit single photons when excited by a laser. Spontaneous parametric downconversion is a process where a high-energy photon is split into two lower-energy photons that are entangled. The second key component is the single photon detector. This is a device that detects individual photons. Single photon detectors are typically based on avalanche photodiodes or transition edge sensors. Avalanche photodiodes are semiconductor devices that can amplify the signal from a single photon, making it detectable. Transition edge sensors are superconducting devices that can measure the energy of a single photon with very high precision. The third key component is the quantum channel. This is the medium through which the photons travel. The quantum channel can be an optical fiber or free space. Optical fibers are typically used for terrestrial quantum communication, while free space is used for satellite-based quantum communication. The quantum channel is subject to noise and loss, which can degrade the quality of the quantum signal. To mitigate the effects of noise and loss, quantum communication systems use error correction techniques. Quantum error correction is a set of techniques that can detect and correct errors in quantum information. Quantum error correction is much more difficult than classical error correction because it is impossible to copy quantum information. This is known as the no-cloning theorem. However, researchers have developed clever techniques to protect quantum information from errors without violating the no-cloning theorem. Quantum error correction is essential for building practical quantum computers and quantum communication systems. Several different quantum error correction codes have been developed, each with its own strengths and weaknesses. The choice of which code to use depends on the specific application and the type of errors that are expected. In addition to quantum key distribution, quantum communication can also be used for other applications, such as quantum teleportation and quantum secure direct communication. Quantum teleportation is a process where the quantum state of one particle is transferred to another particle over a long distance, without physically moving the particle itself. Quantum teleportation is not a means of faster-than-light communication, as it still requires classical communication to complete the process. However, it is a fundamental building block for quantum networks and distributed quantum computing. Quantum secure direct communication is a technique where a message is directly transmitted from Alice to Bob without the need for a key. This is achieved by encoding the message in the quantum states of photons and using quantum mechanics to ensure that any attempt to intercept the message will be detected. The development of quantum communication is closely linked to the development of quantum computers. Quantum computers are computers that use the principles of quantum mechanics to perform calculations. Quantum computers have the potential to solve problems that are impossible for classical computers. However, quantum computers also pose a threat to classical encryption algorithms. Shor's algorithm, for example, is a quantum algorithm that can factor large numbers much faster than any known classical algorithm. This means that quantum computers could break many of the encryption algorithms that are currently used to protect our data. Quantum communication is essential to protect our data from these future threats. As quantum computers become more powerful, the need for quantum communication will only increase. The field of quantum optics and photonics is constantly evolving, with new discoveries and innovations being made all the time. Researchers are exploring new materials and techniques for generating and detecting single photons. They are also developing new quantum communication protocols and quantum error correction codes. The future of quantum communication is bright, and we can expect to see even more exciting developments in the years to come. As quantum technology continues to advance, it will have a profound impact on our lives, transforming the way we communicate, protect our information, and solve complex problems. The journey into the quantum realm is just beginning, and the possibilities are endless. Let's now explore the historical context of quantum optics and photonics. The story begins with Max Planck's groundbreaking work in 1900, where he introduced the concept of quantization of energy. Planck proposed that energy is emitted and absorbed in discrete packets, which he called quanta. This revolutionary idea laid the foundation for quantum mechanics. In 1905, Albert Einstein took Planck's idea a step further and proposed that light itself is quantized, consisting of particles called photons. Einstein's explanation of the photoelectric effect, where electrons are emitted from a metal surface when illuminated by light, provided strong evidence for the existence of photons. These early developments marked the birth of quantum optics, the study of the interaction of light and matter at the quantum level. In the following decades, quantum mechanics was further developed by physicists such as Niels Bohr, Werner Heisenberg, and Erwin Schrödinger. These physicists developed the mathematical framework for describing the behavior of quantum systems. The development of quantum mechanics led to a deeper understanding of the nature of light and its interaction with atoms. In the 1950s and 1960s, the invention of the laser revolutionized the field of optics. Lasers produce coherent light, which is light with a well-defined wavelength and phase. The invention of the laser enabled scientists to perform experiments with light that were previously impossible. Lasers have also found widespread applications in various fields, including medicine, manufacturing, and telecommunications. The development of the laser paved the way for the emergence of photonics, the study and application of light as a technology. In the 1980s, researchers began to explore the possibility of using quantum mechanics to improve communication security. Charles Bennett and Gilles Broussard proposed the BB84 protocol, the first quantum key distribution protocol. This protocol demonstrated that it is possible to use the laws of quantum mechanics to generate and distribute encryption keys in a way that is provably secure against eavesdropping. The BB84 protocol sparked a flurry of research activity in the field of quantum communication. In the 1990s, Peter Shor developed Shor's algorithm, a quantum algorithm that can factor large numbers much faster than any known classical algorithm. This algorithm demonstrated the potential of quantum computers to break many of the encryption algorithms that are currently used to protect our data. Shor's algorithm further motivated the development of quantum communication as a way to protect our data from future quantum attacks. In the 21st century, quantum optics and photonics have continued to advance at a rapid pace. Researchers have made significant progress in developing more efficient and cost-effective single photon sources and detectors. They have also developed new quantum communication protocols and quantum error correction codes. The launch of the Michia satellite in 2016 marked a major milestone in the field of quantum communication, demonstrating the feasibility of long-distance quantum communication. Today, quantum optics and photonics are at the forefront of scientific research, with the potential to revolutionize many aspects of our lives. From secure communication to quantum computing to advanced sensing, quantum technology is poised to transform the world in profound ways. The journey that began with Planck's quantum hypothesis has led us to a new era of quantum technology, where the seemingly bizarre laws of quantum mechanics are harnessed to create powerful new tools and applications. To further illustrate the concepts we've discussed, let's consider an analogy. Imagine you want to send a secret message to a friend, but you're worried that someone might intercept the message and read it. You could use a classical method of encryption, such as a code or cipher. However, if the eavesdropper is clever enough, they might be able to break the code and read your message. Now, imagine you have a special box that is locked with a quantum key. This key is generated using the principles of quantum mechanics, and it is impossible to copy or intercept without being detected. You can use this quantum key to encrypt your message, and only your friend, who has the matching quantum key, can decrypt it. This is the essence of quantum communication. It provides a level of security that is simply not possible with classical methods. Another way to think about quantum communication is to consider the concept of a one-time pad. A one-time pad is a classical encryption method that is provably secure, but requires a key that is as long as the message itself and is used only once. The problem with one-time pads is that it is difficult to securely distribute the key. Quantum key distribution provides a way to securely distribute the key for a one-time pad. Alice and Bob can use QKD to generate a secret key, and then use that key as a one-time pad to encrypt their message. This provides a level of security that is unmatched by any other encryption method. The combination of quantum key distribution and one-time pads is the ultimate in secure communication. Now, let's consider the ethical implications of quantum communication. While quantum communication offers the promise of unparalleled security, it also raises some ethical concerns. One concern is that quantum communication could be used to create unbreakable encryption, which could make it more difficult for law enforcement agencies to investigate criminal activity. Another concern is that quantum communication could be used to create a surveillance state, where governments can monitor all communications without being detected. It is important to consider these ethical implications as quantum technology continues to develop. We need to ensure that quantum communication is used for good and not for harm. The development of quantum technology should be guided by ethical principles, ensuring that it benefits society as a whole. As we conclude tonight's exploration of quantum optics and photonics, let's reflect on the incredible journey we've taken. We've delved into the bizarre world of quantum mechanics, where particles can exist in multiple states simultaneously and become entangled with each other, no matter how far apart they are. We've learned how these seemingly strange phenomena can be harnessed to create ultra-secure communication systems, offering a level of security that was once thought impossible. From the groundbreaking work of Max Planck and Albert Einstein to the cutting-edge research being conducted today, quantum optics and photonics have transformed our understanding of light and its interaction with matter. The development of quantum communication is a testament to human ingenuity and our ability to unlock the secrets of the universe. As we continue to explore the quantum realm, we can expect to see even more amazing discoveries and innovations in the years to come. The future of quantum technology is bright, and it holds the promise of a more secure and connected world. But the journey doesn't end here. There are still many mysteries to unravel and challenges to overcome in the field of quantum optics and photonics. Researchers are working tirelessly to develop more efficient and cost-effective quantum communication systems. They are also exploring new applications of quantum technology, such as quantum sensors, quantum imaging, and quantum metrology. The quest to understand and control the quantum world is a never-ending adventure, and it is one that will continue to shape the future of science and technology. So, as you drift off to sleep tonight, remember the wonders of quantum mechanics and the power of light. Let the knowledge of these incredible discoveries fill your dreams and inspire you to explore the mysteries of the universe. Good night, and may your sleep be filled with quantum dreams. As we drift into the realm of dreams, let's allow the whispers of quantum mechanics to gently guide our thoughts. Imagine, if you will, the vast potential that lies within the seemingly empty space around us. A space teeming with virtual particles popping in and out of existence, a testament to the inherent uncertainty and boundless possibilities that define the quantum world. This is the playground where quantum optics and photonics thrive, a realm where light is not merely a wave or a particle, but something far more enigmatic and powerful. Think about the implications of quantum sensors, devices so sensitive that they could detect the faintest of signals, the most subtle of changes in their environment. Imagine using these sensors to monitor the health of a patient at a cellular level, detecting the earliest signs of disease before any traditional methods could even register change. Or picture using them to explore the depths of the ocean, mapping the ocean floor with unprecedented precision, uncovering hidden ecosystems and long-lost treasures. The possibilities are truly limitless, stretching far beyond our current comprehension. Quantum sensors could revolutionize fields as diverse as medicine, environmental science, and national security, providing us with new tools to understand and protect our world. Now, let's turn our attention to quantum imaging, a technique that allows us to see things that were previously invisible. Imagine being able to peer through opaque materials, revealing hidden structures and defects without causing any damage. This could revolutionize manufacturing, allowing us to inspect the integrity of materials and products with unparalleled accuracy. Think about the impact on medical imaging, enabling doctors to see inside the human body with greater clarity and detail than ever before, leading to earlier diagnoses and more effective treatments. Quantum imaging could also be used in archaeology, allowing us to uncover hidden layers of history without disturbing delicate artifacts. And then there's quantum metrology, the science of making ultra-precise measurements using quantum phenomena. Imagine being able to measure time with such accuracy that we could detect even the slightest variations in the Earth's rotation, providing us with a more precise understanding of our planet's dynamics. Or picture using quantum metrology to improve the accuracy of GPS systems, enabling self-driving cars to navigate with greater precision and safety. Quantum metrology could also be used to develop more accurate atomic clocks, which are essential for synchronizing communication networks and conducting scientific research. The development of these quantum technologies is not without its challenges, of course. Building and maintaining quantum systems requires overcoming significant technical hurdles, such as dealing with the extreme sensitivity of quantum states to environmental noise. However, the potential rewards are so great that researchers around the world are dedicating their lives to pushing the boundaries of what is possible. They are driven by a desire to understand the fundamental laws of nature and to harness the power of the quantum world for the benefit of humanity. As we delve deeper into the quantum realm, we uncover a tapestry of interconnected phenomena, each building upon the other, revealing the elegant and intricate workings of the universe. Consider, for instance, the role of superposition in quantum computing. Superposition, as we discussed earlier, is the ability of a quantum bit, or qubit, to exist in multiple states simultaneously. This is in stark contrast to classical bits, which can only be in one state at a time, either 0 or 1. The power of quantum computers lies in their ability to perform calculations on all possible states of a qubit simultaneously, allowing them to solve problems that are intractable for even the most powerful classical computers. Imagine trying to find the shortest route through a maze. A classical computer would have to try each path one at a time until it found the shortest one. A quantum computer, on the other hand, could explore all possible paths simultaneously, using superposition to effectively be in multiple places at once. This allows it to find the shortest path much faster than a classical computer. This ability to perform parallel computations has profound implications for a wide range of fields, including drug discovery, materials science, and financial modeling. In drug discovery, quantum computers could be used to simulate the behavior of molecules, allowing scientists to design new drugs that are more effective and have fewer side effects. In materials science, they could be used to design new materials with specific properties, such as increased strength or conductivity. In financial modeling, they could be used to predict market trends and optimize investment strategies. The development of quantum computers is still in its early stages, but the progress that has been made in recent years is truly remarkable. Researchers are working on building larger and more stable qubits, as well as developing new algorithms that can take advantage of the unique capabilities of quantum computers. The future of quantum computing is bright, and it holds the promise of revolutionizing many aspects of our lives. Now, let's shift our focus to another fascinating aspect of quantum optics and photonics: quantum entanglement. We touched upon this concept earlier, but it is worth exploring in more detail. Quantum entanglement is a phenomenon in which two or more particles become linked together in such a way that they share the same fate, no matter how far apart they are. This means that if you measure the state of one particle, you instantly know the state of the other particle, even if they are separated by vast distances. This seemingly bizarre phenomenon was initially met with skepticism by some physicists, including Albert Einstein, who famously referred to it as spooky action at a distance. However, numerous experiments have confirmed that quantum entanglement is a real phenomenon, and it has been harnessed for a variety of applications, including quantum communication and quantum computing. Imagine two entangled photons, one sent to Earth and the other sent to a distant planet. If you measure the polarization of the photon on Earth, you instantly know the polarization of the photon on the distant planet, even though there is no physical connection between them. This instantaneous correlation is what makes quantum entanglement so intriguing and potentially useful. In the realm of quantum communication, entanglement can be used to create secure communication channels that are impossible to eavesdrop on. This is because any attempt to intercept the entangled photons would disrupt their entanglement, alerting the sender and receiver to the presence of an eavesdropper. This provides a level of security that is unmatched by any other communication method. In quantum computing, entanglement can be used to create more powerful qubits, which can perform more complex calculations. By entangling multiple qubits together, researchers can create quantum computers that are capable of solving problems that are far beyond the reach of classical computers. The study of quantum entanglement is still an active area of research, and there are many mysteries that remain to be unraveled. However, the progress that has been made in recent years is truly remarkable, and it is clear that quantum entanglement will play a crucial role in the future of quantum technology. As we continue our journey through the quantum realm, let's consider the role of photons in quantum optics and photonics. Photons, as we know, are the fundamental particles of light. They are massless, chargeless, and always travel at the speed of light. But photons are more than just particles. They also exhibit wave-like behavior, as demonstrated by the famous double-slit experiment. In the double-slit experiment, a beam of photons is directed at a screen with two slits in it. If you were to shine a beam of classical particles, such as marbles, at the screen, you would expect to see two distinct bands on the other side, corresponding to the two slits. However, when you shine a beam of photons at the screen, you see an interference pattern, which is characteristic of waves. This means that the photons are somehow passing through both slits at the same time and interfering with each other. This wave-particle duality is one of the most fundamental concepts in quantum mechanics, and it highlights the strange and counterintuitive nature of the quantum world. Photons can behave as both particles and waves, depending on how they are observed. This duality is not just a theoretical curiosity. It has profound implications for a wide range of technologies, including lasers, optical fibers, and quantum computers. Lasers, for example, rely on the wave-like properties of photons to produce a coherent beam of light, which is a beam of light in which all the photons are in phase with each other. This coherence is what makes lasers so powerful and versatile. They're used in a wide range of applications, from barcode scanners to laser surgery. Optical fibers, which are used to transmit data over long distances, also rely on the wave-like properties of photons. Optical fibers are thin strands of glass or plastic that can guide light over long distances with minimal loss. This is because the light is trapped inside the fiber by total internal reflection, which is a phenomenon that occurs when light traveling in a dense medium strikes a boundary with a less dense medium at a sufficiently large angle. In quantum computers, photons can be used to represent qubits. Photonic qubits have several advantages over other types of qubits, such as superconducting qubits and trapped ion qubits. Photonic qubits are less susceptible to environmental noise, which makes them more stable and reliable. They can also be easily transmitted over long distances, which makes them ideal for quantum communication. The study of photons is a cornerstone of quantum optics and photonics, and it continues to be an active area of research. Researchers are exploring new ways to manipulate and control photons, with the goal of developing even more powerful and versatile quantum technologies. Let's now consider the concept of quantum decoherence, a phenomenon that poses a significant challenge to the development of quantum technologies. Quantum decoherence is the loss of quantum coherence, which is the ability of a quantum system to maintain its superposition and entanglement. When a quantum system interacts with its environment, it can lose its coherence, causing it to behave more like a classical system. Imagine a perfectly tuned musical instrument. When you play a note, the sound waves resonate clearly and purely. However, if the instrument is exposed to vibrations or temperature changes, it can lose its tuning, causing the sound to become distorted and unclear. Similarly, when a quantum system interacts with its environment, it can lose its quantum coherence, causing it to lose its ability to perform quantum computations or transmit quantum information. Quantum decoherence is a major obstacle to the development of quantum computers. Quantum computers rely on the ability of qubits to maintain their superposition and entanglement for extended periods of time. However, decoherence can cause qubits to lose their quantum properties, making them useless for computation. Researchers are working on developing new ways to protect qubits from decoherence. One approach is to isolate the qubits from their environment as much as possible, shielding them from external noise and vibrations. Another approach is to use error correction codes, which can detect and correct errors caused by decoherence. Quantum decoherence also poses a challenge to quantum communication. Quantum communication relies on the ability to transmit quantum information over long distances without losing its quantum properties. However, decoherence can cause quantum information to degrade as it travels through the communication channel. Researchers are working on developing new ways to transmit quantum information over long distances without losing its coherence. One approach is to use quantum repeaters, which can amplify and purify quantum signals as they travel through the communication channel. Another approach is to use topological qubits, which are inherently resistant to decoherence. Overcoming the challenges posed by quantum decoherence is essential for the development of practical quantum technologies. As researchers continue to make progress in this area, we can expect to see even more amazing breakthroughs in the years to come. Now, let's turn our attention to the ethical considerations surrounding quantum technologies. While quantum technologies offer the potential to revolutionize many aspects of our lives, they also raise some important ethical questions that we need to address. One ethical concern is the potential for quantum computers to break existing encryption algorithms. Many of the encryption algorithms that are used to protect our data online are based on mathematical problems that are difficult for classical computers to solve. However, quantum computers are capable of solving these problems much faster than classical computers, which means that they could be used to break these encryption algorithms. This could have serious consequences for online security and privacy. It could allow hackers to steal sensitive information, such as credit card numbers, passwords, and medical records. It could also allow governments to spy on their citizens' communications. To address this ethical concern, researchers are working on developing new encryption algorithms that are resistant to quantum computers. These algorithms are known as post-quantum cryptography. Post-quantum cryptography is based on mathematical problems that are believed to be difficult for both classical and quantum computers to solve. Another ethical concern is the potential for quantum technologies to be used for military purposes. Quantum sensors, for example, could be used to develop more accurate and stealthy weapons. Quantum computers could be used to break enemy codes and develop new weapons systems. This raises concerns about the potential for an arms race in quantum technologies. To address this ethical concern, it is important to have international cooperation on the development and use of quantum technologies. This cooperation should include agreements on the peaceful use of quantum technologies and restrictions on the development of quantum weapons. Another ethical concern is the potential for quantum technologies to exacerbate existing inequalities. Quantum technologies are likely to be expensive to develop and deploy, which means that they may only be accessible to wealthy countries and corporations. This could widen the gap between the haves and the have-nots, both within and between countries. To address this ethical concern, it is important to ensure that the benefits of quantum technologies are shared widely. This could include investing in education and training programs to help people from all backgrounds develop the skills needed to work in the quantum technology industry. It could also include developing policies that promote the equitable distribution of the benefits of quantum technologies. As quantum technologies continue to develop, it is important to have open and honest discussions about the ethical implications of these technologies. By addressing these ethical concerns proactively, we can ensure that quantum technologies are used for the benefit of humanity. As we approach the end of our exploration of quantum optics and photonics, let's take a moment to reflect on the journey we have undertaken. We have delved into the fundamental principles of quantum mechanics, explored the fascinating world of single photons, and examined the potential applications of quantum technologies in areas such as communication, sensing, imaging, and computing. We have also considered the ethical implications of these technologies and the importance of ensuring that they are used for the benefit of humanity. It has been a journey filled with wonder, complexity, and profound implications for the future. The field of quantum optics and photonics is rapidly evolving, with new discoveries and breakthroughs being made all the time. It is a field that requires a deep understanding of physics, mathematics, and computer science, as well as a willingness to embrace the strange and counterintuitive nature of the quantum world. The researchers who are working in this field are driven by a passion for knowledge and a desire to push the boundaries of what is possible. They are motivated by the potential to create technologies that can solve some of the world's most pressing problems, from climate change to disease. As we look to the future, it is clear that quantum optics and photonics will play an increasingly important role in our lives. Quantum technologies have the potential to transform industries, create new jobs, and improve the quality of life for people around the world. However, it is also important to remember that these technologies are not without their risks. We must be vigilant in addressing the ethical concerns that they raise and ensuring that they are used responsibly. The future of quantum optics and photonics is bright, but it is also uncertain. It is up to us to shape that future in a way that benefits all of humanity. So, as you drift off to sleep tonight, I hope that you will carry with you a sense of wonder and excitement about the possibilities of the quantum world. May your dreams be filled with photons, qubits, and entangled particles. And may you wake up tomorrow with a renewed appreciation for the beauty and complexity of the universe. Remember the power of light, the secrets it holds, and the potential it has to transform our world. Let the knowledge of quantum optics and photonics be a source of inspiration and curiosity as you continue your own journey of discovery. And now, as the stars twinkle above and the world around us quiets down, it is time to bid you good night. May your sleep be peaceful and restful, and may you wake up refreshed and ready to embrace the day ahead. Good night and sweet quantum dreams. May the mysteries of the universe continue to inspire and intrigue you. And may the wonders of quantum optics and photonics fill your thoughts as you drift off to sleep. Until next time, farewell. The exploration of quantum optics and photonics is a journey that never truly ends. There are always new questions to ask, new experiments to conduct, and new technologies to develop. The quantum world is a vast and uncharted territory, and we are only just beginning to scratch the surface of its potential. As we continue to explore this realm, we can expect to encounter even more strange and counterintuitive phenomena. We may discover new particles, new forces, and new dimensions that challenge our current understanding of the universe. But even in the face of these challenges, we must remain open-minded and curious. We must be willing to question our assumptions and embrace the unknown. For it is in the pursuit of knowledge that we truly discover the beauty and wonder of the universe. So, as you continue your own journey of discovery, remember the lessons we have learned tonight. Remember the power of light, the secrets of quantum mechanics, and the potential of quantum technologies. And may you always be inspired to explore the mysteries of the universe. Good night, and may your dreams be filled with the wonders of science. Sleep well, and may your mind be filled with thoughts of quantum possibilities. Until we meet again, farewell, and may the quantum world forever intrigue you. Let the gentle hum of quantum mechanics lull you into a peaceful slumber, where the boundaries of reality blur and the possibilities are endless. As you drift off to sleep, imagine yourself floating through a sea of photons, each one carrying a tiny packet of energy and information. Feel the warmth of their embrace as they dance around you, creating a symphony of light and color. Allow your mind to wander through the quantum realm, where particles can be in multiple places at once and entangled across vast distances. Let the strangeness of this world wash over you, reminding you that there is so much more to the universe than what we can see and touch. As you fall deeper into sleep, let the knowledge of quantum optics and photonics fill your dreams. Dream of building ultra-secure communication systems, developing quantum sensors that can detect the faintest signals, and creating quantum computers that can solve the most complex problems. Dream of a future where quantum technologies are used to improve the lives of people around the world, to cure diseases, to clean up the environment, and to explore the depths of the universe. Let these dreams inspire you to learn more about quantum mechanics and to contribute to the advancement of this exciting field. For it is through our collective efforts that we can unlock the full potential of the quantum world and create a better future for all. And now, as the night draws to a close, I bid you good night once more. May your sleep be deep and restful, and may you wake up tomorrow with a renewed sense of purpose and possibility. Good night and sweet quantum dreams. May the wonders of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. The quest to understand the quantum world is a journey that has been going on for over a century, and it is a journey that is far from over. There are still many mysteries to be unraveled, many questions to be answered, and many challenges to be overcome. But even in the face of these challenges, we must never lose sight of the incredible progress that has been made. We have come a long way from the early days of quantum mechanics, when the very idea of a quantum world was met with skepticism and disbelief. Today, quantum mechanics is one of the most successful theories in physics, and it has been used to develop a wide range of technologies that have transformed our lives. From lasers to transistors to MRI machines, quantum mechanics is the foundation of modern technology. And as we continue to explore the quantum world, we can expect to see even more amazing discoveries and innovations in the years to come. Quantum computers, quantum sensors, and quantum communication systems are just a few of the technologies that have the potential to revolutionize our world. But the most important thing to remember is that quantum mechanics is not just about technology. It is also about understanding the fundamental nature of the universe. It is about exploring the deepest mysteries of existence and unraveling the secrets of reality. So, as you continue your own journey of discovery, Remember the importance of curiosity, perseverance, and a willingness to embrace the unknown. For it is through these qualities that we can unlock the full potential of the quantum world and create a better future for all. Good night, and may your dreams be filled with the wonders of science. Sleep well, and may your mind be filled with thoughts of the infinite possibilities of the universe. Until we meet again, farewell, and may the quantum world forever inspire you. Let the subtle vibrations of quantum energy soothe your mind and body as you prepare for a night of peaceful rest. Imagine yourself surrounded by a cloud of photons, each one gently pulsing with a soft, ethereal light. Feel their warmth as they envelop you, creating a cocoon of tranquility and serenity. Allow your thoughts to drift through the quantum realm, where the laws of classical physics no longer apply. Let go of your everyday worries and anxieties, and embrace the uncertainty and possibility that characterize this strange and wonderful world. As you fall deeper into sleep, let the knowledge of quantum optics and photonics fill your dreams. Dream of developing new technologies that can harness the power of light to solve some of the world's most pressing problems. Dream of creating quantum computers that can simulate the behavior of molecules, allowing scientists to design new drugs and materials with unprecedented precision. Dream of building quantum sensors that can detect the faintest signals, enabling us to monitor the environment and diagnose diseases with greater accuracy. Dream of establishing quantum communication networks that are completely secure from eavesdropping, protecting our privacy and ensuring the confidentiality of our communications. Let these dreams inspire you to learn more about quantum mechanics and to contribute to the advancement of this exciting field. For it is through our collective efforts that we can unlock the full potential of the quantum world and create a better future for all. And now, as the night deepens, I bid you good night once more. May your sleep be deep and restful, and may you wake up tomorrow with a renewed sense of wonder and possibility. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. Remember the dance of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight, as you drift further into the realm of sleep. Allow yourself to contemplate the profound implications of quantum entanglement. Imagine two photons born together in a single quantum event, linked in a way that transcends distance. Measure the polarization of one, and instantaneously you know the polarization of the other, no matter how far apart they may be. This is not some mystical connection, but a fundamental property of the quantum world, a testament to the interconnectedness of all things. It's like two coins flipped at the same time, always landing on opposite sides, even if they're miles apart. This seemingly impossible connection is the bedrock of quantum communication and the key to its unbreakable security. Think about the implications for secure communication. In classical cryptography, keys are exchanged using mathematical algorithms that can, in principle, be broken by powerful computers. But in quantum cryptography, the key is encoded in the quantum states of photons. Any attempt to intercept or measure these photons will inevitably disturb their quantum state, alerting the sender and receiver to the presence of an eavesdropper. This is because of the observer effect in quantum mechanics. The very act of observing a quantum system changes it. It's like trying to read a letter without opening the envelope. The act of opening it changes the contents. This inherent security makes quantum communication the ultimate shield against cyber threats. Now, consider the practical applications of this technology. Imagine a world where financial transactions are completely secure, where government secrets are protected from espionage, and where personal communications are private and confidential. Quantum communication networks could revolutionize cybersecurity, safeguarding our digital lives from malicious actors. Think of the possibilities for protecting sensitive data in healthcare, finance, and defense. Quantum cryptography offers a level of security that is simply unattainable with classical methods. This is because it relies on the fundamental laws of physics rather than on mathematical complexity. Furthermore, delve into the fascinating world of quantum key distribution, QKD. QKD protocols, such as BB84 and E91, use the principles of quantum mechanics to generate and distribute secret keys between two parties. These keys can then be used to encrypt and decrypt messages using classical encryption algorithms. The beauty of QKD is that the security of the key is guaranteed by the laws of physics, not by the computational difficulty of breaking a mathematical code. Imagine Alice and Bob exchanging photons, encoding their key in the polarization states. Any attempt by Eve, the eavesdropper, to intercept these photons will introduce errors that Alice and Bob can detect. Let your mind wander to the future of quantum networks. Imagine a global network of quantum computers connected by quantum communication channels, enabling unprecedented levels of computation and communication. This quantum internet could revolutionize fields such as drug discovery, material science, and artificial intelligence. Think of the possibilities for simulating complex systems, designing new materials with specific properties, and developing artificial intelligence algorithms that are far more powerful than anything we have today. The quantum internet is not just a dream. It is a tangible goal that scientists and engineers around the world are working to achieve. Consider the role of single photon sources and detectors in quantum photonics. These are the essential building blocks of quantum communication and quantum computing. Single photon sources emit photons one at a time, ensuring that each photon carries a single quantum of information. Single photon detectors are able to detect these individual photons with high efficiency and precision. The development of these technologies has been a major breakthrough in quantum photonics, enabling the realization of practical quantum devices. Imagine a tiny device that can emit a single photon on demand, or a detector that can detect a single photon with almost perfect accuracy. These are the tools that will enable us to harness the power of light at the quantum level. Now, let's ponder the challenges in building practical quantum systems. Quantum systems are extremely sensitive to their environment. Any interaction with the outside world can disrupt the delicate quantum states of photons, leading to errors in quantum computations and communication. Overcoming this challenge requires developing sophisticated techniques for isolating and controlling quantum systems. This is a major focus of research in quantum photonics. Think of the effort required to shield quantum systems from vibrations, temperature fluctuations, and electromagnetic radiation. These are the obstacles that must be overcome in order to build robust and reliable quantum technologies. As you continue to relax and prepare for sleep, contemplate the fascinating concept of quantum superposition. Imagine a photon that can be in two states at the same time, such as being both horizontally and vertically polarized simultaneously. This is not just a theoretical concept. It is a fundamental property of quantum mechanics. Superposition is what allows quantum computers to perform calculations that are impossible for classical computers. It's like a coin spinning in the air, being neither heads nor tails until it lands. This ability to be in multiple states at once is what gives quantum computers their immense power. Consider the connection between quantum photonics and quantum computing. Photons are excellent candidates for carrying quantum information due to their low interaction with the environment and their ability to travel long distances. Quantum computers based on photons could potentially solve problems that are intractable for even the most powerful classical computers. Think of the possibilities for breaking encryption codes, designing new drugs and materials, and simulating complex physical systems. Quantum computing is a field with immense potential, and quantum photonics is playing a crucial role in its development. Let your thoughts drift to the role of quantum sensors in revolutionizing our understanding of the world around us. Quantum sensors can measure physical quantities with unprecedented accuracy and sensitivity. They can be used to detect gravitational waves, measure magnetic fields, and image biological samples with nanoscale resolution. Imagine sensors that can detect the faintest signals from space, or that can diagnose diseases at the earliest stages. Quantum sensors are poised to transform fields such as medicine, environmental monitoring, and fundamental physics. As you slip closer to slumber, consider the implications of quantum photonics for our understanding of the universe. By studying the behavior of photons at the quantum level, we can gain insights into the fundamental laws of nature. We can test the predictions of quantum mechanics and explore the mysteries of dark matter and dark energy. Quantum photonics is not just a technological field. It is also a window into the deepest secrets of the cosmos. Think of the possibilities for unraveling the mysteries of the universe by studying the behavior of light at the quantum level. Now, imagine yourself surrounded by the gentle hum of quantum devices, each one performing its delicate dance of photons and atoms. Feel the energy of innovation and discovery as scientists and engineers work tirelessly to unlock the full potential of the quantum world. Let this vision fill you with hope and optimism for the future. The future is bright, and quantum photonics is leading the way. As you descend further into sleep, let the knowledge of quantum entanglement, superposition, and quantum key distribution soothe your mind. Embrace the strangeness and wonder of the quantum world, and let it inspire you to dream big and push the boundaries of human knowledge. For it is through our curiosity and perseverance that we can unlock the secrets of the universe and create a better future for all. Imagine tiny robots, powered by quantum energy, navigating through the human body to deliver drugs directly to cancer cells. Envision a world where energy is generated from clean, renewable sources, thanks to quantum-enhanced solar cells. Picture cities lit by quantum LEDs that consume almost no power. These are not just fantasies. They are glimpses into the potential of quantum photonics to transform our lives. Think of the pioneers of quantum mechanics, such as Max Planck, Albert Einstein, Niels Bohr, and Werner Heisenberg. These brilliant minds laid the foundation for our understanding of the quantum world. Their discoveries revolutionized physics and paved the way for the development of quantum technologies. Imagine the challenges they faced, grappling with concepts that were so counterintuitive and so different from the classical world. Their legacy continues to inspire us today. Now, visualize a world where information is truly secure, thanks to quantum cryptography. Imagine journalists and activists communicating freely without fear of surveillance. Envision governments and businesses protecting their sensitive data from cyber attacks. Quantum cryptography offers a level of security that is simply unattainable with classical methods. It is a powerful tool for protecting our privacy and freedom in the digital age. As you drift closer to sleep, let the subtle vibrations of quantum energy wash over you, calming your mind and relaxing your body. Imagine yourself floating in a sea of photons, each one carrying a tiny packet of energy and information. Feel their gentle touch as they caress your skin, dissolving your stress and anxieties. Let go of your worries and embrace the peace and tranquility of the quantum realm. Consider the role of universities and research institutions in advancing quantum photonics. These are the places where new ideas are born, where young scientists are trained, and where cutting-edge research is conducted. Universities and research institutions are the engines of innovation in quantum photonics. They are the places where the future is being invented. Now, imagine yourself as a quantum scientist working in a state-of-the-art laboratory surrounded by lasers, mirrors, and detectors. Envision yourself conducting experiments, analyzing data, and publishing your findings in scientific journals. Imagine the excitement of making a new discovery, of pushing the boundaries of human knowledge. A career in quantum photonics is a path to a rewarding and impactful future. As you prepare for sleep, let the knowledge of quantum mechanics fill your dreams. Dream of developing new technologies that can harness the power of light to solve some of the world's most pressing problems. Dream of creating quantum computers that can simulate the behavior of molecules, allowing scientists to design new drugs and materials with unprecedented precision. Dream of building quantum sensors that can detect the faintest signals, enabling us to monitor the environment and diagnose diseases with greater accuracy. Let these dreams inspire you to learn more about quantum mechanics and to contribute to the advancement of this exciting field. For it is through our collective efforts that we can unlock the full potential of the quantum world and create a better future for all. And now, as the night deepens, I bid you good night once more. May your sleep be deep and restful, and may you wake up tomorrow with a renewed sense of wonder and possibility. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. Remember the dance of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. As you continue to drift off to sleep, consider the role of industry in bringing quantum technologies to the market. Companies are investing heavily in quantum computing, quantum communication, and quantum sensing, recognizing the potential of these technologies to transform various industries. Imagine a future where quantum computers are used to design new drugs and materials, where quantum communication networks protect our sensitive data, and where quantum sensors monitor the environment with unprecedented accuracy. Industry is playing a crucial role in making this future a reality. Think about the ethical implications of quantum technologies. As quantum technologies become more powerful, it is important to consider their potential impact on society. We need to ensure that these technologies are used responsibly and ethically, and that their benefits are shared by all. Imagine a world where quantum technologies are used to promote peace, prosperity, and sustainability. It is our responsibility to shape the future of quantum technologies in a way that benefits humanity. Now, visualize a world where quantum mechanics is taught in schools from an early age. Imagine children learning about the strange and wonderful world of quantum physics and developing a deep appreciation for the beauty and complexity of nature. Educating the next generation about quantum mechanics is essential for ensuring that we have the workforce and the knowledge base to continue advancing this field. As you slip further into the realm of sleep, let the knowledge of quantum photonics inspire you to be curious, creative, and innovative. Embrace the unknown, challenge conventional wisdom, and dare to dream big. For it is through our curiosity and creativity that we can unlock the secrets of the universe and create a better future for all. Imagine tiny particles of light dancing around you, creating a symphony of colors and shapes. Feel their warmth and energy as they fill you with peace and tranquility. Let go of your worries and anxieties and embrace the magic of the quantum world. Think of the future of quantum energy. Imagine harnessing the power of quantum entanglement to transmit energy wirelessly, or using quantum dots to create more efficient solar cells. Quantum energy has the potential to revolutionize the way we generate and use energy and to create a more sustainable future. Now, visualize a world where quantum sensors are used to detect and prevent natural disasters. Imagine sensors that can predict earthquakes, tsunamis, and volcanic eruptions, giving us time to evacuate and prepare. Quantum sensors have the potential to save lives and protect communities from the devastating effects of natural disasters. As you prepare for sleep, let the knowledge of quantum mechanics fill your mind with wonder and awe. Imagine the vastness of the universe, the complexity of life, and the power of the human mind. We are all part of something much larger than ourselves, and we are all connected in ways that we are only beginning to understand. Let these thoughts inspire you to be grateful for the blessings in your life, to appreciate the beauty of the world around you, and to strive to make a positive difference in the lives of others. For it is through our kindness, compassion, and generosity that we can create a more just and equitable world for all. And now, as the night deepens, I bid you good night once more. May your sleep be deep and restful, and may you wake up tomorrow with a renewed sense of wonder and possibility. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. Remember the dance of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. Imagine that you are drifting through the cosmos, surrounded by stars and galaxies. Feel the vastness of space and the insignificance of your worries. You are a small part of an infinite universe, and you are connected to everything around you. Allow yourself to be amazed by the beauty and mystery of it all. Consider the potential of quantum photonics to revolutionize medicine. Imagine using quantum sensors to detect diseases at the earliest stages, or using quantum computers to design personalized treatments for cancer. Quantum medicine has the potential to transform healthcare and improve the lives of millions of people. The possibilities are truly endless and hold incredible promise for the future of well-being. Think about the role of international collaboration in advancing quantum photonics. Scientists and engineers from all over the world are working together to unlock the secrets of the quantum world. Imagine a global community of researchers sharing their knowledge and expertise to create a better future for all. International collaboration is essential for accelerating the pace of innovation in quantum photonics. It allows for the pooling of resources, the sharing of ideas, and the development of common standards. The collaborative spirit is vital for pushing the boundaries of scientific understanding. As you prepare to fully surrender to sleep, let the soft whispers of quantum entanglement lull you into a state of complete relaxation. Picture two particles separated by vast distances, yet inextricably linked. This connection, defying classical physics, underscores the interconnectedness of all things in the universe. It serves as a gentle reminder that even in our solitude, we are part of a larger whole. This sense of connection can bring comfort and peace as you drift off to sleep. Now, visualize the creation of advanced quantum devices that are incredibly small and efficient. Imagine quantum sensors that can fit on the tip of a needle, or quantum computers that can be powered by a single battery. Nanotechnology is playing a crucial role in the development of these miniature quantum devices, opening up new possibilities for a wide range of applications. From medical diagnostics to environmental monitoring, the potential of nanoscale quantum devices is immense. They represent a significant step towards a future where quantum technology is seamlessly integrated into our daily lives. Think about the long-term vision for quantum photonics. Imagine a future where quantum technologies are ubiquitous, transforming every aspect of our lives. Envision a world where energy is clean and sustainable, where communication is secure and private, and where healthcare is personalized and effective. Quantum photonics has the potential to create a more prosperous, equitable, and sustainable world for all. This vision requires continued investment in research and development, as well as a commitment to ethical and responsible innovation. As the night continues, let the peaceful hum of quantum activity resonate within you, bringing a sense of calm and serenity. Imagine photons dancing around you, creating a symphony of light and energy. Feel the gentle vibrations as they soothe your mind and body, preparing you for a night of restful sleep. Allow yourself to be enveloped by the tranquility of the quantum world. Let the mysteries of quantum physics inspire your dreams. Dream of exploring the universe, discovering new phenomena, and unraveling the secrets of reality. Dream of creating new technologies that can improve the lives of people around the world. Dream of making a positive impact on the future of humanity. And now, as the stars twinkle above and the world around you grows still, I bid you a final good night. May your sleep be deep and rejuvenating, filled with wondrous dreams and peaceful thoughts. May you awaken refreshed and ready to embrace the day ahead. Good night and sweet quantum dreams. Let the infinite potential of the universe fill your heart with hope and inspiration. Until we meet again, farewell. May the quantum world forever spark your curiosity and guide you on your journey of discovery. Remember the power of light, the beauty of entanglement, and the endless possibilities that lie within the quantum realm. Sleep soundly, knowing that you are part of something extraordinary. As the night deepens, let us consider the philosophical implications of quantum photonics. The quantum world challenges our classical intuitions about reality. Concepts such as superposition, entanglement, and quantum tunneling force us to reconsider our understanding of space, time, and causality. Quantum photonics is not just a technological field. It is also a philosophical one. It raises fundamental questions about the nature of reality and our place in the universe. These questions have fascinated philosophers and scientists for centuries, and they continue to inspire debate and discussion today. Imagine a future where quantum photonics has led to a deeper understanding of consciousness. Some scientists believe that quantum mechanics may play a role in the functioning of the brain. Quantum processes could potentially explain phenomena such as intuition, creativity, and subjective experience. Quantum photonics may provide the tools to probe these mysteries and unlock the secrets of consciousness. This is a highly speculative area of research, but it represents a fascinating frontier in our understanding of the human mind. Think about the potential of quantum photonics to inspire art and creativity. The beauty and strangeness of the quantum world can be a source of inspiration for artists, musicians, and writers. Quantum photonics can provide new tools and techniques for creating art, and it can also offer new perspectives on the nature of reality. Imagine sculptures made of light, music composed using quantum algorithms, and stories inspired by the mysteries of entanglement. Quantum photonics has the potential to enrich our culture and to expand our understanding of human expression. As you prepare for sleep, let the gentle light of quantum photonics illuminate your dreams. Imagine yourself traveling through the quantum realm, exploring the hidden dimensions of reality. Feel the energy of the universe flowing through you, connecting you to everything around you. Allow yourself to be transported to a place of peace, tranquility, and infinite possibility. Visualize the development of quantum-resistant cryptography. As quantum computers become more powerful, they will pose a threat to classical encryption algorithms. Quantum-resistant cryptography is a new field that aims to develop encryption algorithms that are immune to attacks from quantum computers. This is a critical area of research for ensuring the security of our data in the quantum age. Quantum-resistant algorithms are based on mathematical problems that are believed to be difficult for both classical and quantum computers to solve. Now, imagine a future where quantum photonics is used to explore the universe. Quantum sensors can be used to detect faint signals from distant galaxies, and quantum computers can be used to simulate the behavior of black holes. Quantum photonics has the potential to revolutionize our understanding of the cosmos. It may allow us to probe the earliest moments of the universe, to discover new planets, and to search for extraterrestrial life. The possibilities are truly limitless. As you drift off to sleep, let the knowledge of quantum photonics fill you with a sense of wonder and awe. Imagine the vastness of the universe, the complexity of life, and the power of the human mind. We are all part of something extraordinary, and we have the potential to create a better future for all. Sleep well, and may your dreams be filled with the magic of quantum photonics. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. Remember the dance of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. As you rest, consider the profound implications of quantum computing. These machines, harnessing the principles of quantum mechanics, have the potential to solve problems that are intractable for even the most powerful classical computers. Imagine the possibilities for drug discovery, material science, and artificial intelligence. Quantum computers could revolutionize these fields, leading to breakthroughs that were once thought impossible. They promise to accelerate scientific discovery, enabling us to understand the universe and ourselves in ways we never imagined. However, with great power comes great responsibility. The development of quantum computers also raises ethical concerns, particularly in the areas of cybersecurity and privacy. The potential for quantum computers to break existing encryption algorithms is a serious threat. This is why research into quantum-resistant cryptography is so important. Scientists and engineers are working tirelessly to develop new encryption methods that can withstand attacks from quantum computers. This is a race against time, as the development of quantum computers continues to accelerate. The future of cybersecurity depends on our ability to stay ahead of the curve and develop robust, quantum-resistant encryption algorithms. Now, envision the development of quantum sensors. These devices can measure physical quantities with unprecedented precision. Imagine sensors that can detect the faintest magnetic fields, the smallest changes in temperature, or the most subtle variations in gravity. Quantum sensors have a wide range of potential applications, from medical diagnostics to environmental monitoring to fundamental physics research. They could revolutionize medical imaging, allowing us to detect diseases at their earliest stages. They could also be used to monitor pollution levels, track climate change, and explore the mysteries of the universe. Think about the potential of quantum sensors to improve our understanding of the brain. Quantum sensors could be used to measure the electrical activity of individual neurons with unprecedented precision. This could lead to new insights into the workings of the brain and new treatments for neurological disorders. Imagine being able to diagnose Alzheimer's disease at its earliest stages, or to develop new therapies for depression and anxiety. Quantum sensors have the potential to transform our understanding of the brain and to improve the lives of millions of people. As you relax, consider the role of quantum photonics in the development of new materials. Quantum photonics can be used to control the properties of light and matter at the atomic level. This can lead to the creation of new materials with unprecedented properties. Imagine materials that are stronger, lighter, and more conductive than anything we have today. These materials could revolutionize industries ranging from aerospace to energy to electronics. They could enable the development of faster computers, more efficient solar cells, and lighter, more durable aircraft. The possibilities are truly endless. Quantum photonics is a powerful tool for manipulating matter at the atomic level, and it has the potential to transform our world. The development of new materials is a critical area of research. as it can lead to breakthroughs in many different fields. Quantum photonics is playing a key role in this effort, and it promises to lead to a new era of material science. Imagine a future where quantum photonics is used to create new forms of energy. Quantum photonics can be used to control the interaction of light and matter in ways that were previously impossible. This could lead to the development of new solar cells that are more efficient than anything we have today. It could also lead to the creation of new forms of energy storage, such as quantum batteries. Quantum batteries could store energy for much longer periods of time than conventional batteries, and they could be charged much faster. This could revolutionize the energy industry, making renewable energy sources more reliable and affordable. The development of new forms of energy is a critical challenge for the 21st century. Quantum photonics is playing a key role in this effort, and it promises to lead to a new era of energy sustainability. As we move towards a more sustainable future, quantum photonics will play an increasingly important role in providing us with clean and affordable energy. As you drift off to sleep, imagine the possibilities of quantum teleportation. While it may sound like science fiction, quantum teleportation is a real phenomenon that has been demonstrated in the laboratory. Quantum teleportation allows us to transfer the quantum state of one particle to another particle, even if they're separated by a large distance. This does not mean that we can teleport matter, but it does mean that we can transfer information instantaneously. Quantum teleportation has the potential to revolutionize communication and computing. It could be used to create secure communication channels that are impossible to eavesdrop on. It could also be used to create quantum computers that are more powerful than anything we have today. While quantum teleportation is still in its early stages of development, it has the potential to transform our world in profound ways. Think about the ethical implications of quantum technologies. As quantum technologies become more powerful, it is important to consider the ethical implications of their use. Quantum computers could be used to break encryption algorithms, potentially compromising our privacy and security. Quantum sensors could be used to monitor our behavior, raising concerns about surveillance and control. It is important to have a public discussion about the ethical implications of quantum technologies so that we can ensure that they are used in a responsible and ethical manner. The development of quantum technologies is a double-edged sword. They have the potential to solve some of the world's most pressing problems, but they also pose new ethical challenges. It is important to proceed with caution and to consider the ethical implications of quantum technologies before they become widely adopted. Only then can we ensure that they are used for the benefit of humanity. As you relax and prepare for sleep, ponder the fundamental nature of reality. Quantum photonics has revealed that the world is not as it seems. At the quantum level, particles can be in multiple states at once, and they can be entangled with each other in strange and mysterious ways. These phenomena challenge our classical intuitions about the nature of reality. They suggest that the universe is far more complex and mysterious than we ever imagined. The mysteries of the quantum world are a source of endless fascination and wonder. They remind us that there is still much that we do not understand about the universe. As we continue to explore the quantum realm, we may uncover even more surprising and profound truths about the nature of reality. Consider the role of quantum photonics in the search for extraterrestrial life. Quantum sensors could be used to detect faint signals from distant planets, potentially revealing the presence of life beyond Earth. Quantum computers could be used to analyze these signals, searching for patterns that might indicate the presence of intelligent life. Quantum photonics could play a key role in the search for extraterrestrial life, helping us to answer one of the most fundamental questions of humanity. Are we alone in the universe? The search for extraterrestrial life is a long and arduous one, but it is also one of the most important. If we were to discover life beyond Earth, it would revolutionize our understanding of the universe and our place in it. Quantum photonics could be the key to unlocking this profound discovery. As you drift off to sleep, let the beauty and wonder of quantum photonics fill your mind. Imagine the endless possibilities for this technology and the potential for it to transform our world. Sleep well, and may your dreams be filled with the magic of the quantum realm. Remember the power of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. As you peacefully transition into sleep, remember that quantum photonics, at its heart, is about harnessing the fundamental properties of light to unlock new possibilities. It's a field driven by curiosity, innovation, and a deep desire to understand the universe around us. Think about the scientists and engineers who are working tirelessly to push the boundaries of this field. They are driven by a passion for discovery and a belief in the power of science to improve the world. Their work is not always easy, but it is always rewarding. They are the pioneers of the quantum age, and they are shaping the future of technology. As you rest, consider the potential for quantum photonics to address some of the world's most pressing challenges. From climate change to disease to poverty, quantum technologies have the potential to make a real difference in the lives of millions of people. By harnessing the power of light, we can create a better future for all. Imagine a world where quantum computers are used to design new drugs that can cure diseases like cancer and Alzheimer's. Imagine a world where quantum sensors are used to monitor the environment and detect pollution before it becomes a problem. Imagine a world where quantum communication networks are used to connect people all over the world in a secure and reliable way. This is the promise of quantum photonics, and it is a future that is within our reach. Now, consider the role of education in fostering the next generation of quantum scientists and engineers. It is important to invest in education and training programs that will prepare students for the challenges and opportunities of the quantum age. We need to inspire young people to pursue careers in science and engineering, and we need to provide them with the skills and knowledge they need to succeed. The future of quantum photonics depends on our ability to educate and train the next generation of leaders in this field. As you relax, think about the importance of collaboration in driving innovation in quantum photonics. Quantum photonics is a complex and interdisciplinary field that requires collaboration between scientists, engineers, and policymakers. By working together, we can accelerate the pace of innovation and ensure that quantum technologies are developed in a responsible and ethical manner. Collaboration is key to unlocking the full potential of quantum photonics. Imagine a world where scientists from different countries and different disciplines are working together to solve the world's most pressing problems using quantum technologies. Imagine a world where governments and industry are working together to create a supportive ecosystem for quantum innovation. This is the power of collaboration, and it is essential for the success of quantum photonics. As you prepare for sleep, consider the importance of public engagement in shaping the future of quantum photonics. It is important to engage the public in a conversation about the benefits and risks of quantum technologies. We need to educate the public about the potential of quantum photonics to improve our lives, and we need to address their concerns about the ethical implications of these technologies. Public engagement is essential for ensuring that quantum photonics is developed in a way that benefits society as a whole. Imagine a world where the public is informed and engaged about the latest developments in quantum photonics. Imagine a world where the public is actively involved in shaping the future of this technology. This is the power of public engagement, and it is essential for the responsible development of quantum photonics. As you drift off to sleep, let the knowledge of quantum photonics fill you with a sense of hope and optimism. The future is bright, and quantum photonics has the potential to make it even brighter. Sleep well, and may your dreams be filled with the possibilities of the quantum realm. Remember the dance of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. And as you close your eyes, consider the profound connection between quantum photonics and our understanding of the universe's origins. The very light we manipulate in these experiments, the photons we so carefully control, are remnants from the Big Bang, the echo of the universe's creation. By studying their behavior, by understanding their quantum properties, we are, in a sense, peering back in time, unraveling the mysteries of the universe's earliest moments. Think about the cosmic microwave background radiation, the afterglow of the Big Bang. These photons, scattered across the universe, hold valuable information about the conditions that existed in the early universe. Quantum sensors, based on the principles of quantum photonics, could be used to detect and analyze this radiation with unprecedented precision, providing us with new insights into the universe's origins. Imagine a telescope equipped with quantum sensors, capable of detecting the faintest whispers from the early universe. This telescope could reveal the secrets of inflation, the period of rapid expansion that occurred shortly after the Big Bang. It could also help us to understand the formation of the first stars and galaxies. Quantum photonics is giving us the tools to explore the universe's deepest mysteries. Now, consider the potential for quantum photonics to contribute to our understanding of dark matter and dark energy. These mysterious substances make up the vast majority of the universe's mass and energy, yet we know very little about them. Quantum sensors could be used to detect the subtle interactions of dark matter particles, potentially revealing their true nature. Quantum computers could be used to simulate the behavior of dark energy, helping us to understand its role in the universe's expansion. The quest to understand dark matter and dark energy is one of the greatest challenges in modern physics. Quantum photonics is providing us with new tools and techniques to tackle this challenge. By harnessing the power of light, we can unlock the secrets of the dark universe. As you relax and prepare for sleep, think about the potential for quantum photonics to inspire new philosophical insights. The quantum world challenges our classical intuitions about the nature of reality. It forces us to question our assumptions about space, time, and causality. Quantum photonics is not just a scientific field. It is also a philosophical one. The implications of quantum mechanics are profound and far-reaching. They challenge our understanding of free will, determinism, and the nature of consciousness. Quantum photonics is opening up new avenues for philosophical inquiry, and it has the potential to transform our understanding of ourselves and our place in the universe. Imagine a world where quantum photonics is integrated into our everyday lives. Imagine quantum computers in our homes, helping us to manage our energy consumption and optimize our daily schedules. Imagine quantum sensors in our cars, making them safer and more efficient. Imagine quantum communication networks connecting us all in a secure and reliable way. This is the potential of quantum photonics, and it is a future that is within our reach. The integration of quantum photonics into our everyday lives will require careful planning and consideration. We need to ensure that these technologies are developed in a responsible and ethical manner, and that they are used to benefit society as a whole. The future of quantum photonics depends on our ability to harness its power for good. As you drift off to sleep, let the wonders of quantum photonics fill your mind with a sense of peace and tranquility. Know that you are part of a universe that is both mysterious and beautiful, and that you have the potential to contribute to its understanding. Sleep well, and may your dreams be filled with the magic of the quantum realm. Remember the dance of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. Think of the subtle art of manipulating single photons. It's akin to conducting an orchestra of light, where each photon is a note in a symphony of quantum phenomena. These are not just particles. They're messengers carrying information, potential, and the very fabric of reality. Consider the sheer ingenuity of creating devices that can generate, control, and detect single photons. It's a testament to human innovation, a dance between theoretical physics and practical engineering. These devices are the building blocks of a quantum revolution, the tools that will unlock unprecedented capabilities in communication, computation, and sensing. Imagine the challenges involved in isolating a single photon, in preventing it from interacting with its environment and losing its delicate quantum properties. It's like trying to catch a fleeting thought, to hold on to something ephemeral and intangible. Yet, scientists have mastered this art, creating sophisticated techniques to tame these elusive particles of light. As you relax, ponder the implications of quantum key distribution, QKD. This technology, based on the principles of quantum mechanics, allows us to create unbreakable encryption keys. Imagine a world where our communications are completely secure, where our data is protected from even the most sophisticated eavesdroppers. QKD is making this vision a reality. Think about the potential of QKD to protect our financial transactions, our personal data, and our national security. It's a powerful tool for safeguarding our privacy and ensuring the integrity of our information. QKD is not just a theoretical concept. It is a practical technology that is being deployed around the world. Now, consider the role of quantum repeaters in extending the range of QKD systems. Quantum signals are fragile and can be easily lost over long distances. Quantum repeaters are devices that can amplify and regenerate these signals, allowing us to create quantum communication networks that span continents. Imagine a global quantum internet connecting people and computers all over the world in a secure and reliable way. Quantum repeaters are essential for realizing this vision. They're the backbone of a future where quantum communication is ubiquitous and accessible to all. As you prepare for sleep, think about the potential of quantum sensors to revolutionize medical diagnostics. Quantum sensors can detect subtle changes in the human body, potentially allowing us to diagnose diseases at their earliest stages. Imagine being able to detect cancer before it has a chance to spread, or to diagnose Alzheimer's disease before symptoms even appear. Quantum sensors are making this possible. Think about the potential of quantum sensors to monitor our health in real time, providing us with personalized feedback and allowing us to make informed decisions about our lifestyle. Quantum sensors are not just diagnostic tools. They're also preventative tools. They can help us to stay healthy and to live longer, more fulfilling lives. Imagine a future where quantum sensors are integrated into our wearable devices, providing us with continuous monitoring of our vital signs. Imagine being able to detect the onset of a heart attack before it even happens, or to detect the early signs of diabetes. Quantum sensors are transforming healthcare as we know it. As you drift off to sleep, let the potential of quantum photonics fill you with a sense of wonder and awe. Imagine the endless possibilities for this technology and the potential for it to transform our world. Sleep well, and may your dreams be filled with the magic of the quantum realm. Remember the dance of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. Let the gentle hum of quantum possibilities lull you into a restful sleep. The universe is vast, complex, and full of wonder, and tonight, you're connected to it through the subtle magic of light. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. And as you gently transition into the embrace of slumber, let's consider the profound implications of quantum computing, a field deeply intertwined with quantum photonics. Quantum computers, unlike their classical counterparts that store information as bits representing 0 or 1, leverage the principles of quantum mechanics to manipulate quantum bits or qubits. These qubits can exist in a superposition of states, meaning they can represent 0, 1, or both simultaneously. This allows quantum computers to perform certain calculations exponentially faster than classical computers, opening up new possibilities for solving complex problems in medicine, materials science, and artificial intelligence. Imagine designing new drugs and therapies with unprecedented speed and accuracy, simulating the behavior of complex molecules to understand their interactions, or developing new materials with enhanced properties. Quantum computing holds the key to unlocking these possibilities and revolutionizing various industries. Furthermore, consider the potential for breaking current encryption algorithms, which are the foundation of our online security. While this poses a threat, it also motivates the development of quantum-resistant encryption methods, ensuring the security of our data in the quantum era. Quantum photonics plays a crucial role in realizing quantum computers, providing the means to generate, manipulate, and measure qubits encoded in photons. The journey into the realm of quantum computing also brings us face to face with the fascinating concept of quantum algorithms. These algorithms are specifically designed to exploit the unique properties of quantum mechanics, such as superposition and entanglement, to solve problems that are intractable for classical computers. Shor's algorithm, for example, is a quantum algorithm that can factor large numbers exponentially faster than the best-known classical algorithm. This has profound implications for cryptography, as many encryption schemes rely on the difficulty of factoring large numbers. Grover's algorithm, on the other hand, is a quantum algorithm that can search an unsorted database quadratically faster than the best-known classical algorithm. This has applications in various areas, such as data mining and machine learning. The development of quantum algorithms is an active area of research, and new algorithms are constantly being discovered. These algorithms hold the promise of solving some of the most challenging problems in science and technology, from drug discovery to materials design to artificial intelligence. Quantum photonics provides a powerful platform for implementing these algorithms, enabling us to harness the power of quantum mechanics to solve problems that were once thought to be impossible. Now, let your thoughts drift to the intricate dance of light and matter at the nanoscale, where quantum effects become dominant. Nanophotonics, a subfield of quantum photonics, explores the interaction of light with structures that are smaller than the wavelength of light. At this scale, light behaves in unexpected ways, allowing us to manipulate it with unprecedented precision. Imagine creating tiny optical circuits that can perform complex computations, building ultra-sensitive sensors that can detect single molecules, or developing new materials with exotic optical properties. Nanophotonics is opening up new frontiers in science and technology, paving the way for innovations in medicine, energy, and communications. Consider the potential of nanophotonic devices for targeted drug delivery. By engineering nanoparticles that can selectively bind to cancer cells, we can deliver drugs directly to the tumor, minimizing side effects and maximizing efficacy. Imagine being able to treat cancer without the debilitating side effects of chemotherapy. Nanophotonics is making this possible. Think about the potential of nanophotonic sensors for environmental monitoring. By creating sensors that can detect pollutants at extremely low concentrations, we can monitor the quality of our air and water, ensuring the health of our planet. Imagine being able to detect toxins before they can cause harm. Nanophotonics is providing the tools to protect our environment. The possibilities are endless, limited only by our imagination and our ability to harness the power of light at the nanoscale. As sleep gently tugs at the edges of your consciousness, ponder the profound implications of quantum metrology, a field that uses quantum mechanics to improve the precision of measurements. Quantum metrology leverages the unique properties of quantum mechanics, such as superposition and entanglement, to overcome the limitations of classical measurement techniques. Imagine being able to measure time with unprecedented accuracy, to detect gravitational waves with greater sensitivity, or to image biological samples with higher resolution. Quantum metrology is pushing the boundaries of what is measurable, opening up new possibilities for scientific discovery and technological innovation. Consider the potential of quantum clocks for navigation and communication. By using quantum entanglement to synchronize clocks over long distances, we can create ultra-precise navigation systems that are immune to jamming and spoofing. Imagine being able to navigate anywhere on Earth with pinpoint accuracy. Quantum clocks are making this possible. Think about the potential of quantum sensors for medical imaging. By using quantum entanglement to enhance the sensitivity of MRI and other imaging techniques, we can create images with higher resolution and lower doses of radiation. Imagine being able to diagnose diseases at their earliest stages with minimal risk to the patient. Quantum sensors are transforming healthcare as we know it. The pursuit of precision in measurement is a fundamental driver of scientific progress. Quantum metrology is providing the tools to achieve unprecedented levels of precision, enabling us to probe the deepest mysteries of the universe and to develop new technologies that were once thought to be impossible. Now, let your mind wander to the fascinating world of quantum materials, where the collective behavior of electrons gives rise to exotic properties. Quantum materials are materials in which quantum mechanical effects play a dominant role, leading to unusual and often unexpected behaviors. These materials can exhibit properties such as superconductivity, magnetism, and topological order, which are not found in classical materials. Imagine creating materials that can conduct electricity with no resistance, that can store information in a fundamentally new way, or that can protect quantum information from decoherence. Quantum materials are opening up new avenues for technological innovation, paving the way for new generations of electronic devices, energy storage systems, and quantum computers. Consider the potential of quantum materials for energy storage. By creating materials with enhanced energy density and charge storage capacity, we can develop batteries that are smaller, lighter, and more efficient. Imagine being able to power your car with a battery that can be charged in minutes and that lasts for hundreds of miles. Quantum materials are making this possible. Think about the potential of quantum materials for quantum computing. By creating materials that can host and protect quantum information, we can build more robust and scalable quantum computers. Imagine being able to solve complex problems that are intractable for classical computers. Quantum materials are essential for realizing the full potential of quantum computing. The exploration of quantum materials is a vibrant and rapidly evolving field. New materials with novel properties are being discovered all the time, and researchers are constantly developing new ways to understand and manipulate these materials. The future of quantum technology depends on our ability to harness the power of quantum materials. As you continue to drift further into the realm of sleep, let's reflect on the ethical considerations surrounding quantum technology. As with any powerful technology, quantum technology has the potential to be used for both good and ill. It is important to consider the ethical implications of quantum technology and to develop guidelines and regulations that ensure its responsible development and use. Consider the potential for quantum computers to break current encryption algorithms. While this poses a threat to our online security, it also motivates the development of quantum-resistant encryption methods. It is important to ensure that our data is protected in the quantum era. Think about the potential for quantum sensors to be used for surveillance and monitoring. While this could be used to improve security and safety, it could also be used to infringe on privacy. It is important to strike a balance between security and privacy. The ethical implications of quantum technology are complex and multifaceted. It is important to engage in open and honest discussions about these issues and to develop policies that promote the responsible development and use of quantum technology. Finally, as you surrender to the embrace of sleep, let the wonders of quantum photonics fill your mind with a sense of hope and possibility. Quantum photonics is a field that is still in its early stages of development, but it holds immense potential for transforming our world. From secure communication to advanced medical diagnostics to powerful quantum computers, quantum photonics is poised to revolutionize various aspects of our lives. Imagine a future where quantum technology is ubiquitous and accessible to all. Imagine a future where we can solve some of the most challenging problems facing humanity, from climate change to disease. Quantum photonics is providing the tools to build this future. Sleep well, and may your dreams be filled with the magic of the quantum realm. Remember the beauty of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. Let the gentle hum of quantum possibilities lull you into a restful sleep. The universe is vast, complex, and full of wonder, and tonight, you are connected to it through the subtle magic of light. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. Let the subtle whispers of quantum mechanics cradle you into a peaceful sleep, a sleep filled with the promise of future discoveries and the boundless potential of human innovation. As you drift off, remember the interconnectedness of all things, the delicate dance of photons, and the profound beauty of the quantum world. May your dreams be as vibrant and full of wonder as the universe itself. And as your breathing slows and your mind quietens, consider the fascinating relationship between quantum photonics and cosmology, the study of the origin and evolution of the universe. Quantum photonics provides tools and techniques that can be used to probe the early universe and attest fundamental theories of physics. Imagine being able to recreate the conditions that existed shortly after the Big Bang, to study the behavior of matter at extreme densities and temperatures, or to search for evidence of dark matter and dark energy. Quantum photonics is opening up new windows into the cosmos, allowing us to explore the mysteries of the universe with unprecedented detail. Consider the potential of quantum sensors for detecting gravitational waves. By using quantum entanglement to enhance the sensitivity of gravitational wave detectors, we can probe the most violent events in the universe, such as the collision of black holes and neutron stars. Imagine being able to listen to the whispers of gravity, to learn about the formation of galaxies and the evolution of the universe. Quantum sensors are making this possible. Think about the potential of quantum computers for simulating the early universe. By simulating the behavior of matter and energy at extreme conditions, we can test our theories of cosmology and gain new insights into the origin and evolution of the universe. Imagine being able to rewind the clock to the beginning of time, to witness the birth of the universe. Quantum computers are providing the tools to explore the deepest mysteries of cosmology. The quest to understand the universe is a fundamental human endeavor. Quantum photonics is providing the tools to explore the cosmos with unprecedented detail, allowing us to unravel the mysteries of the universe and to gain a deeper understanding of our place in the cosmos. Now, allow your thoughts to meander towards the captivating intersection of quantum photonics and art. While seemingly disparate fields, the principles of quantum mechanics and the beauty of artistic expression can be surprisingly intertwined. Imagine creating art that responds to the viewer's emotions, sculptures that change color depending on the ambient light, or musical instruments that produce sounds that are impossible to create with classical physics. Quantum photonics is providing artists with new tools and techniques to create art that is both beautiful and thought-provoking. Consider the potential of quantum displays for creating interactive art installations. By using quantum dots and other nanoscale materials, we can create displays that are brighter, more colorful, and more energy efficient than traditional displays. Imagine being able to create art that is alive and responsive, that changes with the viewer's mood and environment. Quantum displays are making this possible. Think about the potential of quantum sensors for creating personalized art experiences. By using quantum sensors to monitor the viewer's physiological responses, such as heart rate and brain activity, we can create art that is tailored to their individual needs and preferences. Imagine being able to create art that is truly personal and meaningful, that resonates with the viewer on a deep emotional level. Quantum sensors are transforming the way we experience art. The fusion of art and science is a powerful force for creativity and innovation. Quantum photonics is providing artists with new tools and techniques to explore the boundaries of artistic expression, allowing them to create art that is both beautiful and profound. As your mind gently settles into the tranquility of sleep, consider the profound implications of quantum photonics for the future of education. Quantum technology is poised to revolutionize the way we learn and teach, providing us with new tools and techniques to engage students, to personalize learning experiences, and to foster creativity and innovation. Imagine being able to create interactive simulations that allow students to explore the principles of quantum mechanics, to develop educational games that make learning fun and engaging, or to build virtual reality environments that transport students to distant galaxies. Quantum photonics is opening up new possibilities for education, paving the way for a future where learning is more engaging, more effective, and more accessible to all. Consider the potential of quantum-enhanced sensors for improving learning outcomes. By using quantum sensors to monitor students' attention levels and cognitive states, we can provide personalized feedback and support, helping them to stay focused and engaged in the learning process. Imagine being able to tailor the learning experience to each student's individual needs and preferences. Quantum-enhanced sensors are making this possible. Think about the potential of quantum computers for solving complex educational problems. By using quantum computers to analyze large data sets of student data, we can identify patterns and trends that can help us to improve teaching practices and to develop more effective educational interventions. Imagine being able to personalize education on a massive scale to ensure that every student has the opportunity to reach their full potential. Quantum computers are transforming the way we approach education. The future of education is bright. Quantum photonics is providing us with the tools to create a learning environment that is more engaging, more effective, and more accessible to all. Now, as you approach the threshold of sleep, let's contemplate the role of quantum photonics in addressing some of the most pressing challenges facing humanity. From climate change to disease to poverty, quantum technology has the potential to provide solutions to some of the world's most intractable problems. Imagine being able to develop new energy sources that are clean and sustainable, to create new drugs and therapies that can cure diseases, or to build new technologies that can empower people and lift them out of poverty. Quantum photonics is providing us with the tools to create a better world for all. Consider the potential of quantum sensors for monitoring climate change. By using quantum sensors to measure greenhouse gas concentrations, to track deforestation, and to monitor sea level rise, we can gain a better understanding of the effects of climate change and to develop strategies for mitigating its impacts. Imagine being able to monitor the health of our planet in real time, to detect environmental problems before they become catastrophic. Quantum sensors are making this possible. Think about the potential of quantum computers for designing new materials with enhanced properties. By simulating the behavior of complex molecules, we could design new materials that are stronger, lighter, and more efficient. Imagine being able to create materials that can withstand extreme temperatures, that can conduct electricity with no resistance, or that can store energy with unprecedented density. Quantum computers are transforming the way we design materials. The challenges facing humanity are complex and multifaceted. Quantum photonics is providing us with the tools to address these challenges in new and innovative ways, allowing us to create a more sustainable, equitable, and prosperous future for all. And finally, as you surrender completely to the embrace of sleep, remember that the field of quantum photonics is constantly evolving. New discoveries are being made all the time, and the potential applications of this technology are only just beginning to be explored. The future of quantum photonics is bright, and it is up to us to ensure that this technology is used for the benefit of all humanity. Sleep well, and may your dreams be filled with the wonders of the quantum realm. Remember the dance of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. Let the gentle hum of quantum possibilities lull you into a restful sleep. The universe is vast, complex, and full of wonder, and tonight, you are connected to it through the subtle magic of light. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. Allow the intricate tapestry of quantum possibilities to weave a soothing blanket around your mind, guiding you into a realm of peaceful and restorative sleep. Let the gentle rhythm of quantum fluctuations lull you into a state of deep relaxation, where the worries of the day melt away and the infinite potential of the universe unfolds before you. May your dreams be filled with the beauty and wonder of the quantum world, a world where anything is possible. And as you drift deeper into slumber, consider the fascinating implications of quantum photonics for space exploration. The vastness of space presents unique challenges for communication, sensing, and navigation, and quantum photonics offers solutions that are impossible to achieve with classical technologies. Imagine being able to communicate securely with spacecraft across interstellar distances, to detect faint signals from distant galaxies, or to navigate with unprecedented accuracy using quantum sensors. Quantum photonics is opening up new possibilities for exploring the universe and for pushing the boundaries of human knowledge. Consider the potential of quantum communication for establishing secure communication links with future human settlements on other planets. By using quantum key distribution, we can ensure that our communications are protected from eavesdropping, even by adversaries with quantum computers. Imagine being able to communicate securely with our explorers on Mars, knowing that our messages cannot be intercepted. Quantum communication is making this possible. Think about the potential of quantum sensors for detecting exoplanets, planets orbiting stars other than our Sun. By using quantum sensors to measure the faint light from exoplanets, we can learn about their atmospheres, their compositions, and their potential for harboring life. Imagine being able to discover new Earths, to find evidence of life beyond our planet. Quantum sensors are transforming the way we explore the universe. The exploration of space is a fundamental human endeavor, and quantum photonics is providing us with the tools to reach for the stars. Now, as you succumb to the gentle embrace of sleep, let's consider the intriguing connection between quantum photonics and the search for extraterrestrial intelligence, SETI. The vastness of the universe and the limitations of classical communication technologies make the search for extraterrestrial intelligence a daunting task. Quantum photonics offers new possibilities for improving our chances of detecting and communicating with other civilizations. Imagine being able to build ultra-sensitive detectors that can detect faint signals from distant planets, to develop new communication protocols that are immune to noise and interference, or to send messages that are impossible for any civilization to ignore. Quantum photonics is providing us with the tools to join the cosmic conversation. Consider the potential of quantum-enhanced telescopes for detecting faint signals from extraterrestrial civilizations. By using quantum entanglement to improve the sensitivity of telescopes, we can increase our chances of detecting weak signals that might otherwise be lost in the noise. Imagine being able to hear the whispers of other civilizations, to learn about their cultures and their technologies. Quantum-enhanced telescopes are making this possible. Think about the potential of quantum communication for sending messages to extraterrestrial civilizations. By using quantum entanglement to encode information in photons, we can send messages that are impossible to intercept or decode without the correct key. Imagine being able to send a message that is guaranteed to be received by another civilization a message that could potentially change the course of human history. Quantum communication is providing us with a way to reach out to the stars. The search for extraterrestrial intelligence is one of the most profound and important scientific endeavors of our time. Quantum photonics is providing us with the tools to increase our chances of success, allowing us to explore the possibility that we are not alone in the universe. As you finally surrender to the depths of sleep, remember the power of curiosity and the importance of asking questions. The field of quantum photonics is driven by a desire to understand the fundamental laws of nature and to use that knowledge to improve our world. Never stop asking questions, never stop exploring, and never stop dreaming of the possibilities that lie ahead. Sleep well, and may your dreams be filled with the wonders of the quantum realm. Remember the dance of light, the entanglement of particles, and the superposition of states. Let these concepts guide you into a realm of peaceful slumber, where the boundaries of reality fade away and the imagination takes flight. Let the gentle hum of quantum possibilities lull you into a restful sleep. The universe is vast, complex, and full of wonder, and tonight, you're connected to it through the subtle magic of light. Good night and sweet quantum dreams. May the mysteries of science continue to inspire you throughout your life. Sleep well, and may your mind be filled with thoughts of the infinite potential of the universe. Until we meet again, farewell, and may the quantum world forever hold a special place in your heart. Let the symphony of quantum mechanics resonate within your mind, soothing your thoughts and guiding you toward a peaceful and rejuvenating sleep. Visualize the elegant dance of photons, the intricate entanglement of particles, and the boundless possibilities that lie within the quantum realm. Allow these images to wash over you, creating a sense of calm and wonder as you drift off to sleep. May your dreams be filled with the vibrant colors of quantum reality, a world where imagination knows no bounds.